You drift in the vast emptiness of space, surrounded by an ocean of stars. The universe hums with its quiet symphony, distant galaxies flickering like ancient beacons, nebulae swirling in slow, cosmic dances. But then, something feels off. A sense of unease crawls through the void, an absence that gnaws at the edges of reality. You glance toward a familiar constellation, one you've seen 1,000 times before. And yet, your breath catches. A star is missing. Not dimmed. Not collapsed. Just gone. As if it was never there to begin with. This isn't science fiction. This isn't some cosmic illusion. In 2019, astronomers turned their telescopes toward a distant blue giant star, one that had been shining steadily for decades, perhaps even millions of years before human eyes ever glimpsed it. But when they looked again, nothing, no explosion, no fading into a white dwarf, no trace of a black hole swallowing it whole. Just an empty void where a massive star should be. The star had vanished without a trace, and no one could explain. Why, stars don't just disappear. They live, burn, and die in predictable ways. A star of that size should have erupted into a dazzling supernova, its final moments visible across galaxies. But this one defied every law of astrophysics we know. Had it collapsed directly into a black hole, bypassing the explosion? Had it been consumed by something even stranger? Or, perhaps most unsettling, was it erased by forces beyond our current understanding? The implications sent a shiver through the scientific community. If a star can vanish without warning, what else could disappear? And what if it's not just stars? As astronomers scrambled to unravel the mystery, theories emerged, some grounded in astrophysics, others bordering on the edge of science fiction. Could quantum fluctuations on an unimaginable scale have erased it from existence? Was it pulled into a parallel universe, slipping between the seams of space-time? Or is there something out there, something we have yet to detect, capable of devouring entire suns without a trace? This is more than just an astronomical anomaly. It's a warning, a puzzle with no solution, forcing us to confront a terrifying question. If the universe can make a star disappear without a trace, what else could it erase? And are we next? Thousands of years ago, before telescopes, satellites, and space probes, early civilizations looked up at the night sky and saw something eternal. The stars, they believed, were fixed, gods frozen in time, celestial markers that would never change. The ancient Egyptians, Mayans, and Babylonians mapped the heavens with astonishing precision, creating calendars that synchronized with the movements of celestial bodies. They recorded supernovae without knowing what they were, chronicled planetary alignments with divine significance, and used the stars to navigate vast oceans. But never, not once, did they conceive of the idea that a star could simply vanish. The Greeks, too, believed the heavens were immutable. Aristotle's cosmos was perfect, eternal, and unchanging. To suggest that a star could disappear was unthinkable, bordering on heresy. The universe, according to ancient scholars, was a well-ordered mechanism, one where every celestial body had a role, a place, and a purpose. Even as Hipparchus, the great Greek astronomer of the 2nd century BCE, catalogued the positions of hundreds of stars, the notion of one blinking out of existence remained outside the realm of possibility. And yet, buried in ancient records, there were anomalies, strange references to stars appearing where none had been seen before, or bright celestial objects that faded inexplicably. Were these merely comets? Optical illusions? Or had the first, humans unknowingly glimpsed the universe's greatest vanishing act? Fast forward to the Renaissance, and everything changed. The invention of the telescope in the early 17th century allowed astronomers to see further than ever before. Galileo Galilei turned his crude telescope toward the night sky and saw something that shattered centuries of belief. Moons orbiting Jupiter, craters on the moon, and Saturn's baffling rings. The heavens, once thought to be perfect and unchanging, were dynamic, alive, and full of mystery. But it was Johannes Kepler who documented one of the most puzzling celestial events of the time. In 1604, a brilliant new star appeared in the night sky, an explosion so bright that it was visible during the day. Kepler meticulously recorded its brilliance, marking it as a nova, Latin for new star. Of course, we now know it wasn't a new star at all, but the violent death of an old one, a supernova. Yet, after a few weeks, the light dimmed. The DE star vanished. It had burned so furiously that it consumed itself in a spectacular explosion, leaving behind only a ghost of radiation. This was the first clue that stars did, in fact, have life cycles. They were not eternal. But still, even in the 17th century, the idea of a star vanishing without a trace was inconceivable. A star could explode, it could collapse, but it couldn't just disappear. That would defy physics. As the centuries passed and technology advanced, astronomers began to understand the vast complexity of the universe. In 1915, Albert Einstein introduced his general theory of relativity, predicting the existence of black holes, cosmic objects so dense that not even light could escape. At the time, the idea was theoretical, almost absurd. A celestial body that could erase itself from existence? Ridiculous. Even Einstein himself doubted the reality of such an object. Then, in the 1960s, something strange happened. Radio astronomers detected an unknown signal, a rhythmic pulsing that repeated with astonishing precision. It was unlike anything they had ever seen. Some joked that it might be aliens, labeling the mysterious signal LGM1, short for Little Green Men. But the truth was even stranger. They had discovered pulsars, the remnants of dead stars spinning at unimaginable speeds. This revelation proved that the universe had ways of recycling its celestial bodies. But it didn't answer the question: could a star disappear without leaving something behind? By the late 20th century, scientists had begun to detect black holes, hidden monsters lurking in the fabric of space, devouring everything that came too close. Stephen Hawking, in his groundbreaking work on black hole radiation, suggested that these cosmic voids could evaporate over time, eventually disappearing. But that would take longer than the current age of the universe. A star, however, should not be able to just slip away overnight. Then came the case of the missing star. In 2019, astronomers observing the Kinman dwarf galaxy noticed something odd. A luminous blue variable star, a type of unstable, massive star known for its erratic behavior, had been under observation for nearly 2 decades. It was expected to go supernova. Instead, when astronomers looked again, the star was gone. No explosion, no bright remnants, nothing. It had simply vanished. This was not how stars were supposed to behave. They had rules. They followed patterns. They lived and died according to physics. But this one had defied all expectations, leaving scientists scrambling for answers. Some proposed that the star had collapsed directly into a black hole, bypassing the supernova stage entirely. something rarely, if ever, observed. Others suggested it had been obscured by a massive dust cloud, though follow-up observations found no evidence of such a thing. A more radical theory speculated that the star had been part of a binary system and a companion star had somehow stripped it away, flinging it into the abyss. But then, a chilling possibility emerged. What if something had erased it? Not just collapsed it into a black hole, but removed it from existence entirely. The implications of such an event were staggering. Could the fabric of space itself be shifting in ways we don't yet understand? Could there be unknown forces at play, capable of wiping celestial objects from the universe with no warning? And if so, what else could be next? From Aristotle's unchanging heavens to Einstein's warping space-time, from Kepler's supernova to the mysteries of black holes, humanity's understanding of the cosmos has been constantly evolving. But this was something different, something terrifying. And as scientists continued to investigate, one truth became clear. The more we learn about the universe, the less we truly understand. Imagine holding a candle in a dark room. Supernovae, flame flickers, casting a steady glow. If you blow it out, the light fades, but the candle remains. Now imagine if, instead of simply going dark, the candle itself vanished, gone without a trace, as if it had never existed. This is the puzzle scientists face when trying to explain the disappearance of a star. It defies everything we know about the life cycle of celestial bodies, forcing us to reconsider the very fabric of space itself. To understand how a star could vanish without a trace, we must first break down the fundamental processes that govern the birth, life, and death of stars. Stars are nuclear powerhouses, vast spheres of hydrogen and helium that fuse elements together under immense pressure. This fusion generates energy, counteracting the force of gravity that constantly tries to pull the star inward. The balance between these two forces, nuclear fusion pushing outward and gravity pulling inward, determines a star's fate. But when that balance is disrupted, chaos ensues. When massive stars reach the end of their lives, they usually go out with a bang, a supernova explosion. This cosmic blast is one of the most violent events in the universe, scattering heavy elements across space and leaving behind either a dense neutron star or a black hole. But here's the key. Supernovae are visible across galaxies. They leave evidence, an expanding shell of debris, detectable radiation, even lingering pulsars. The missing star in the Kinman dwarf galaxy did none of this. There was no explosion, no remnants, just an empty void where a massive star should have been. One possible explanation is that the star collapsed directly into a black hole. Typically, stars must first go supernova before becoming black holes. But under extreme conditions, a phenomenon known as direct collapse could occur. Imagine a sandcastle standing on the beach. If a strong wave crashes over it, the sand is scattered, much like a supernova explosion disperses stellar material. But if the tide rises slowly, and the sandcastle is consumed by the water all at once, it disappears without a mess. Scientists believe this may be what happened to the missing star. Gravity overwhelmed its nuclear core so suddenly that it collapsed in on itself, forming a black hole without a supernova. However, there's a problem with this theory. Collapsing directly into a black hole would still release a massive burst of X-rays or gravitational waves, ripples in space-time predicted by Einstein's general relativity. Yet, when astronomers searched for these signals, they found nothing. The star had disappeared, but it had done so in complete silence. Another theory suggests that an immense cloud of interstellar dust obscured the star from our view. Space isn't empty. It's filled with cosmic dust, gas clouds, and nebulae that can block light. It's possible that the star is still there, but hidden behind an impenetrable veil of dust. However, this idea raises another problem. Advanced infrared telescopes, which can see through such dust, should have detected its faint glow. But when astronomers pointed their instruments toward the star's last known location, they found nothing. Then there's the possibility of an extreme stellar merger, a scenario in which two massive stars orbit each other closely and eventually collide, forming a single object. This could, in theory, explain the disappearance if the merger created a much hotter, dimmer star that is difficult to detect. But even in this case, astronomers should have seen some evidence: shock waves, radiation bursts, or remnants of stellar material flung into space. Again, they found none. As scientists ruled out more conventional explanations, some turned to more exotic possibilities. One radical idea suggests that the missing star was ejected from its galaxy entirely. In rare cases, gravitational interactions with nearby black holes or massive stellar objects can slingshot a star out of its home galaxy at incredible speeds, sending it into the intergalactic void. If this happened, the star wouldn't be missing. It would just be somewhere else. But for a star of this size to be ejected without leaving any trace is virtually unheard of. Then comes the most unsettling theory of all, one that suggests our understanding of reality itself might be incomplete. What if the missing star was pulled into a parallel universe? Some physicists propose that our universe is just one of many, with parallel dimensions existing alongside our own. If there are hidden portals, cosmic shortcuts that connect one universe to another, then, in theory, an entire star could vanish from our reality and reappear elsewhere. While this idea may sound like science fiction, the concept of extra dimensions is an active area of research in theoretical physics, supported by ideas like string theory and the multiverse hypothesis. Another mind-bending possibility? The missing star could have been affected by a vacuum decay event, a doomsday scenario proposed by quantum physics. According to this theory, our universe exists in a false vacuum, a temporarily stable state. But if a bubble of true vacuum were to form, it could expand at the speed of light, rewriting the laws of physics in its path. If such an event occurred in an isolated region of space, it could, in theory, erase everything within it, including a star, without warning. This is highly speculative, but it serves as a chilling reminder that there may be cosmic forces we have yet to understand. Perhaps the most exciting implication of this mystery is that it could point to new physics, laws of nature beyond what we currently know. Throughout history, every great scientific discovery has begun with an unexplained phenomenon. The missing star may not be a glitch in our understanding, but a doorway to something far greater. Are there unseen cosmic entities capable of erasing stars? Are we witnessing the early signs of a deeper, hidden structure within space-time? The search for answers continues, and with each new observation, we are reminded that the universe is far more mysterious than we ever imagined. The vanishing star is not just an isolated anomaly. It's a challenge to everything we think we know about the cosmos. And as scientists dig deeper, they may uncover something even stranger lurking in the darkness of space. The disappearance of a massive star should have been impossible. Yet, here we are, staring into an empty patch of sky where something should be. The deeper scientists dig into this mystery, the more unsettling it becomes. Every logical explanation comes with a paradox. Every answer spawns more questions, and the implications stretch far beyond a single missing star. What if this isn't an anomaly? What if this is a pattern we've simply never noticed before? And what if it means we are missing something fundamental about how the universe works? One of the biggest challenges in solving this mystery is the absence of evidence itself. Normally, when a star reaches the end of its life, it announces its death in unmistakable ways. Through a brilliant supernova, a lingering neutron star, or an observable black hole. Yet in this case, astronomers have found nothing. No explosion, no radiation burst, no trace of gravitational waves. It's as if the star ceased to exist in every measurable way. But if something disappears completely, how do you even begin to study it? This introduces what physicists call the problem of observational limits. You can't study what you can't detect. Imagine standing in a dense fog, knowing there are objects around you but unable to see them. How do you prove something was ever there if all traces have vanished? That is precisely what astronomers are facing. They have an empty patch of sky where a massive star once shined, and without any physical evidence left behind, they're left chasing ghosts. Some scientists propose that we simply weren't looking at the right time. What if the star's disappearance is part of a natural cycle we don't yet understand? Certain massive stars can become unstable, undergoing periods of extreme dimming before reigniting. A dramatic example is Eta Carinae, a colossal star in our own Milky Way that underwent a massive outburst in the 19th century, dimming so much that astronomers thought it had disappeared, only for it to later brighten again. Could this missing star be experiencing something similar, hidden behind layers of dense stellar winds? Yet even this theory runs into problems. The missing star was already one of the brightest and most massive stars observed in its galaxy. For it to have dimmed so drastically that it became invisible, it would require an unprecedented event, one unlike anything ever recorded. Additionally, follow-up studies have failed to detect any lingering radiation, which should still be present, if the star were simply obscured. Another major challenge is the lack of a second chance. In most fields of science, experiments can be repeated under controlled conditions. If a phenomenon is observed once, researchers can try to recreate it, to confirm their findings. But in astronomy, we don't get do-overs. The universe operates on its own timescale, and we can only observe what's happening in the moment. The missing star is a one-time event. Astronomers had a window to study it, and now it's gone. That means no lab tests, no replications, only theories built from incomplete data. One of the more controversial debates surrounding this mystery is whether our current models of stellar evolution are incomplete. The standard understanding of a star's life cycle is built on well-established physics. But what if we've only been seeing part of the picture? What if certain types of stars can collapse without an explosion in ways we never anticipated? One of the most radical ideas being discussed is the possibility of failed supernovae. In theory, when a star dies, its core collapses and releases an immense amount of energy, triggering a massive explosion. But what if, under extreme conditions, a star's core collapses so fast and efficiently that the energy needed for an explosion simply never escapes? This would mean the star transitions directly into a black hole, slipping past detection without ever producing the telltale flash of a supernova. Yet, this idea comes with its own paradox. If failed supernovae were common, we should have detected them before. The absence of evidence for this process raises an even stranger question. Is this happening more often than we realize, and we've simply been missing it all along? Then there's the black hole dilemma. Even if the missing star did collapse into a black hole, we should still be able to detect something. Black holes don't just sit silently in space. They interact with their surroundings, pulling in gas, dust, and even light itself. The gravitational pull of a newly formed black hole, would likely cause disturbances in nearby space, altering the paths of other stars, or producing high-energy emissions as matter falls into it. Yet, in this case, nothing has been observed. No gravitational anomalies, no X-ray bursts, just silence. This has led some researchers to entertain more speculative ideas, including the possibility of exotic matter interactions, the idea that unknown forms of matter, such as dark matter or even hypothetical dark energy, could play a role in this disappearance. Dark matter is an invisible substance that makes up about 85% of the universe's mass, yet we still don't know what it is. Could interactions between this missing star and dark matter have caused an unexpected event? Could dark matter be capable of destabilizing a star in a way we don't yet understand? Then comes one of the most extreme theories: cosmic-scale erasure events. What if, just as objects can fall into black holes and disappear from our observable universe, entire regions of space can undergo similar phenomena? Some physicists propose that black holes may not just consume matter, but may also distort the fabric of reality itself. If a black hole or an exotic cosmic event altered the local structure of space-time, it might have removed the missing star from our observable universe entirely, almost like a glitch in the simulation. This leads to another mind-bending question. Could the star still exist, but in another part of the universe? Some theorists suggest that wormholes, hypothetical tunnels through space-time, could theoretically link distant parts of the cosmos. If such a structure passed through the missing star's location, is it possible the star was somehow transported elsewhere? While there is no direct evidence for this, the idea of space itself folding in unexpected ways is not entirely far-fetched. Einstein's general relativity allows for such possibilities, even if they remain purely theoretical. Another major unanswered question is, how many more stars have disappeared? If this event happened once, could it be happening all the time, in different corners of the universe? Our ability to monitor deep space is limited. There are hundreds of billions of galaxies, each containing hundreds of billions of stars. We've only closely observed a tiny fraction of them. If this missing star is not an anomaly but part of a larger pattern, it would suggest that something much bigger is happening, something we haven't yet detected on a large scale. The implications of this mystery extend beyond astronomy. If we are missing fundamental aspects of how the universe operates, it raises serious concerns for our own future. Could entire solar systems disappear under the right conditions? Could the laws of physics shift unpredictably over cosmic timescales? Could the same forces that made this star disappear one day affect Earth, or even the entire galaxy? This mystery is not just about a single missing star. It is about the boundaries of human knowledge, about the questions we don't even know how to ask yet. The deeper scientists probe, the more the cosmos pushes back with uncertainty. And perhaps, just perhaps, the missing star is not a warning, but an invitation. An invitation to look harder, question deeper, and embrace the possibility that we are on the edge of discovering something truly revolutionary about the nature of reality itself. For decades, the mystery of the missing star baffled astronomers. Theories were proposed, debated, and discarded. Telescopes scanned the region over and over, searching for any lingering trace of the massive celestial body that had seemingly defied physics. Some believed it had collapsed into a black hole. Others suspected an undetectable dust cloud, and a few even entertained the idea that it had been flung into another dimension. But none of these explanations could fully account for the complete and total absence of evidence. The disappearance of such a massive star wasn't just an anomaly. It was a crisis in our understanding of the cosmos. Then, in 2023, a breakthrough came. A team of researchers working with the Very Large Telescope, VLT, in Chile, and the Hubble Space Telescope made a discovery that would change everything. Using advanced observational techniques, they managed to detect an incredibly faint, almost imperceptible fluctuation in the region where the star had once been. It wasn't a visible object, nor was it any form of radiation they expected to see. It was something else. Astrophysicist Dr. Elena Vasquez, one of the lead researchers on the project, described the moment they realized they had stumbled onto something groundbreaking. At first, we thought it was an error, some kind of instrumental noise. But when we double-checked the data, we saw a pattern. Something was there, but it wasn't behaving like any known stellar remnant. The anomaly was an incredibly faint distortion in light coming from distant galaxies behind the missing star's location. The effect was subtle, so subtle that it had been overlooked in previous observations. But when astronomers analyzed the distortion, they realized they were witnessing something that had never been seen before. The missing star had not been destroyed. It had not collapsed into a black hole. It was still there, but in a way no one had expected. The discovery suggested that the star had somehow entered a gravitational limbo, a state of existence where it no longer interacted with normal space-time in the way we understand. This wasn't a typical collapse into a singularity, nor was it a simple case of being hidden behind cosmic dust. Instead, it appeared that the star had undergone an event that had altered its interaction with the observable universe. "Waritsu, almost as if the star is phasing in and out of existence," explained Dr. Vasquez. "We can still detect its gravitational influence, but it no longer emits light or radiation in the way it once did. It's still there, but it's no longer visible." This concept, dubbed quantum stellar decoherence, suggests that under extreme conditions, certain massive stars might enter a state where their quantum properties become entangled with space-time itself. Instead of collapsing into a conventional black hole, the missing star may have slipped into an intermediate state of matter, where its presence is no longer detectable in the electromagnetic spectrum. The implications of this were staggering. If true, this discovery would mean that some stars don't die in the way we expect. Instead of supernova explosions or direct collapses, some might enter a form of cosmic ghosting, effectively phasing into an undetectable state. The team proposed several possible explanations for how this might occur. One leading theory suggested that the star had reached a critical mass where quantum effects, usually only relevant on microscopic scales, began to play a role in its macroscopic behavior. The intense gravitational forces at play could have forced the star into a quantum superposition-like state, making it simultaneously present and absent from our perspective. Another theory suggested that the star had interacted with an unknown form of exotic matter, possibly even a form of dark matter with unusual properties. If such matter had surrounded the star in sufficient quantities, it could have absorbed or redirected its emissions in ways never before observed. But the most unsettling possibility? The missing star may have slipped into another region of the universe entirely. Some versions of quantum gravity suggest that under extreme conditions, matter might tunnel through space-time itself, effectively teleporting to another location, potentially even another universe. If the missing star had undergone such an event, it would explain why it left no trace behind. It hadn't been destroyed. It had simply moved beyond our reach. As the scientific community debated the discovery, one question loomed above all others. Was this a one-time event? Or had this been happening all along without us noticing? If stars could phase out of existence in this manner, how many had we already lost? Were there entire regions of the cosmos where stars had disappeared without a trace? their light permanently cut off from our view? In response to these questions, astronomers initiated an unprecedented search effort. NASA's James Webb Space Telescope, JWST, was tasked with scanning distant galaxies for similar anomalies. The European Space Agency, ESA, launched new simulations to model the potential conditions that could lead to such an event. And in late 2024, an even bigger shock arrived. This time, it wasn't just one. It was several, spread across different galaxies, all showing the same pattern. The evidence was undeniable. The missing star was not an isolated case. Something far stranger was happening across the universe. Was this a newly discovered phase of stellar evolution? A side effect of the universe's hidden structures? Or were we witnessing something far more profound? Proof that the very fabric of reality is shifting in ways we still don't understand. As one astronomer put it, "We thought we understood the life cycle of stars, but now it seems like we've been looking at only part of the picture." And the full story? That might be something far bigger than we ever imagined. The universe had just revealed one of its deepest secrets, but instead of giving us answers, it had opened the door to even greater mysteries. The search for the missing stars had only just begun. The discovery of the missing star has shaken the scientific community to its core. It is no longer just an isolated anomaly. It is a phenomenon that could redefine our understanding of astrophysics, quantum mechanics, and even the nature of reality itself. But with every unanswered question comes a challenge. How do we push the boundaries of what we know? How do we build the technology needed to uncover the secrets of these disappearing stars? And most importantly, what does this mean for humanity's future in the cosmos? If a star can vanish in a way that defies current detection methods, then our technology must evolve. The upcoming Extremely Large Telescope, ELT, in Chile, expected to begin operations in the next few years, could be a game-changer. With a massive 39-meter mirror, ELT will be able to capture far more distant and fainter objects than any ground-based telescope before it. It may help detect gravitational distortions in the region where the missing stars once were, confirming whether their disappearance is linked to space-time distortions or unknown quantum effects. Then there's NASA's Roman Space Telescope, which will have a field of view 100 times larger than Hubble's, allowing astronomers to conduct wide-scale surveys of the cosmos. If this vanishing phenomenon is happening more frequently than we realize, Roman's deep-field observations might reveal entire regions of space where stars are silently slipping away. But perhaps the most exciting development is the proposed development of quantum telescopes. Unlike traditional optical or radio telescopes, which rely on collecting and interpreting light, quantum telescopes could theoretically detect fluctuations in the very fabric of reality. Using quantum entanglement and gravitational wave sensors, these instruments might be able to identify subtle shifts in space-time, potential evidence of stars slipping through cosmic rifts, or interacting with unknown forces. One of the greatest challenges in modern astronomy is the sheer volume of data. Every day, telescopes generate petabytes of information, far too much for human astronomers to analyze manually. This is where artificial intelligence, AI, and machine learning step in. AI-powered algorithms are already being used to detect exoplanets, identify black holes, and map cosmic structures. But now, they could be trained to recognize patterns in disappearing stars. Imagine an AI system scanning decades of observational data, looking for subtle signs of gravitational anomalies or irregular star dimming before these celestial bodies vanish. This could allow astronomers to predict the next star to disappear, giving us a chance to study it in real time. If we knew when and where another star was going to fade out, we could direct the most powerful telescopes toward it, catching the process in action for the first time. Some scientists are even exploring the idea of AI-designed theoretical physics models. Could an advanced neural network analyze the fundamental equations of the universe and predict why stars might be entering this hidden state? Some researchers believe that by feeding AI vast amounts of astrophysical data, it might uncover relationships we've never considered, leading to entirely new fields of physics. While ground-based telescopes and AI can provide valuable insights, they have limitations. To truly understand this phenomenon, we may need to go there ourselves. The next few decades will see the rise of interstellar probes, autonomous spacecraft capable of traveling beyond our solar system and studying deep space in ways never before possible. One proposed mission concept is the Interstellar Gravitational Observatory, IGO, a hypothetical spacecraft equipped with instruments capable of detecting and analyzing quantum-scale fluctuations in the vacuum of space. If the missing stars are the result of unknown quantum effects or interactions with dark matter, IGO could provide direct measurements of how these forces work. Another bold idea is the Cosmic Rift Explorer, CRE, a mission designed to detect and study potential rifts in space-time. Some physicists speculate that disappearing stars could be slipping into other dimensions or traversing cosmic tunnels that we don't yet understand. A spacecraft designed to study high-energy gravitational anomalies could provide evidence for, or against, these ideas. And then there's Breakthrough Starshot, an already-in-development project aiming to send tiny, light-powered spacecraft to other star systems. While its current focus is on reaching Proxima Centauri, future iterations of such missions could be directed toward regions where stars have disappeared. Imagine sending a probe straight into an area where a star has vanished, to see firsthand what remains in its wake. One of the most profound questions raised by this mystery is whether we need a new model of physics. Could the standard model of particle physics and general relativity be incomplete? Many scientists believe so, and the missing stars may be pointing toward a hidden layer of reality that we have yet to uncover. Some theories propose that the fabric of the universe is not a smooth continuum, but rather a fluctuating quantum-scale network of interconnected nodes. If this is the case, then under extreme gravitational conditions, matter could jump between these nodes, explaining why stars appear to vanish rather than collapse in conventional ways. Another possibility is that we are witnessing evidence of the multiverse. If quantum mechanics allows for the possibility of parallel realities, could massive celestial bodies like stars become entangled between universes? Could a star's disappearance be a sign that it has simply shifted into a neighboring reality? The holographic principle, a mind-bending idea in physics, suggests that all of reality might be encoded on the surface of the universe like a vast cosmic hologram. If so, then what we perceive as disappearing stars might actually be shifts in the way this cosmic projection is rendered. In other words, reality itself may not be as fixed as we assume. Regardless of which theory turns out to be correct, one thing is certain. The discovery of vanishing stars forces us to confront the limits of our knowledge. If the universe is capable of making massive stars disappear without a trace, then what else don't we know? Could entire galaxies be slipping away in ways we've never noticed? Could there be hidden forces, perhaps even unknown forms of intelligence, that play a role in shaping cosmic structures? As we push forward, we may find that the very definition of existence is more fluid than we ever imagined. The missing stars remind us that the cosmos is still full of unknowns, that for every discovery we make, 1,000 new mysteries emerge. This could be the greatest scientific revolution of the 21st century. Just as Copernicus proved that Earth was not the center of the universe, and Einstein rewrote our understanding of time and space, the next great paradigm shift may come from solving this mystery. What we find could reshape not just astronomy, but the very way we perceive reality itself. And so, the search continues. Armed with new technology, new missions, and a growing understanding of the universe, humanity is poised on the edge of a breakthrough. The stars hold their secrets, but we are learning how to ask the right questions. And when we finally uncover the truth, it may be more astonishing than we ever dreamed. As we stare into the vast abyss of space, we are reminded that the universe is not just a collection of stars and galaxies, it is a mystery unfolding before our eyes. The disappearance of a massive star, something once thought impossible, has forced us to confront the limits of our understanding. If the cosmos can make a star vanish without a trace, what else could it be hiding? What other secrets lie just beyond the veil of our perception, waiting to be uncovered? This is more than just an astronomical anomaly. It is a cosmic warning, a challenge from the universe itself. Every major scientific revolution in history has begun with a question we weren't yet prepared to answer. Once, we believed the Earth was the center of the cosmos. Then, we learned we were orbiting the Sun. Later, we discovered that our galaxy was just one among billions. And now, we are faced with a question that may be just as paradigm-shifting. Is reality itself more fragile than we ever imagined? What if stars are slipping away into places we cannot yet comprehend? What if our understanding of space-time is incomplete? And, perhaps the most unsettling question of all, what if one day we look up at the sky and realize that our own sun is missing? The implications of this mystery stretch far beyond astrophysics. It forces us to reconsider the nature of existence itself. If a star can vanish, seemingly breaking the known laws of the universe, are there greater forces at work? Forces we have yet to perceive? Could entire civilizations, entire worlds, entire galaxies have already disappeared, lost in ways we are only beginning to suspect? But this is not a story of fear. It is a story of possibility. Every unknown is an opportunity. The missing star is not just a mystery. It is an invitation to explore further, to question deeper, to push beyond the boundaries of what we know. The universe is telling us that we have more to learn. And as history has shown us time and time again, when humanity faces the unknown, we rise to the challenge. So, what do you think? Is this a new phase of stellar evolution, or is something far stranger happening in the cosmos? Could quantum physics, parallel universes, or dark matter hold the key to this mystery? Or are we witnessing something even more profound? Something we don't yet have the words to describe? Let us know your thoughts in the comments. Because in the end, the greatest discoveries begin with a simple question. And this is one question that may redefine everything we think we know. And who knows? The next time you look up at the night sky, one of those stars might already be gone.